Good afternoon, everyone, or good morning, or good evening, depending upon where you're watching from. Welcome to the Graphisoft Community Workflow webinar series. Now, this is episode 4, and I'm your host, Nathan Hildebrand. Now, if you have missed the previous episodes, I suggest you go over to the Archicad YouTube channel, where you'll be able to catch up on the previous 3 episodes and learn from our fabulous presenters we've had before. But today we have Thomas Graabæk from Formfaktor or Graphisoft Center Denmark. Now, my pronunciation is pretty atrocious, so I always have to apologize to people when I have them as guests. It must have something to do with my Australian personality or characteristics, I don't know.
No problem.
But Thomas is an architect by profession, and he has an extensive professional bio. And, all you need to do is just read that as part of the webinar today. And I don't like to go into that too much detail, but the key thing that I do want to raise is the fact that he has contributed to several industry bodies, and specifically Building Smart, and helping out with creating Building Smart Denmark. I think that's really important in terms of acknowledging that. And has had over 20 years now experience in the AEC industry, spanning various roles as an architect, BIM consultant, and also now as an Archicad reseller. Now, one of the things that people will learn is that I do like to share personal traits that people have when I have them on as guests, because I think that that's more important and more special when you learn a little bit more about people. Now, Thomas is a long distance runner, and I do remember seeing him post a mean or a pretty fast time for a half marathon training. I'm guessing he did late last year. So I think it was 1:34 from memory. So I think that's pretty good for someone
You've been
if you're not
stalking
training
me.
full time. Mate, well, that's what happens when you're friends with someone on Facebook. It's a problem. I'm sure you see all the things I talk about as well. But the key thing is we're not here to joke about marathon or half marathon running today. We're here to talk about life cycle analysis. And I think that one of the things that, I say this with every presentation, and that's why we have these guests on here. All of the presentations you've seen, we put together since we started this webinar series, and the ones you'll see coming on over the next 8 months of the rest of the year, is centered around processes that are actually really, really important for us as Archicad users. Now, Thomas will share with you today the reason why LCA isn't just a new buzzword. It's actually something that's really, really important for us as architects as we move forward, with the focus on sustainability being a key thing for all of us across the world. And we're starting to see a lot of countries actually require this as a deliverable once projects are being designed. But at the same time as explaining this, he'll also demonstrate ways with you in which you can conduct lifecycle analysis within Archicad. Now, throughout the presentation, if you have any questions, please feel free to put them into the chat. At the end of the presentation, I will ask those questions to Thomas on your behalf. Now, if the question has more detail, we may turn on your camera or your microphone to assist us in getting a more detailed question from you. But enough from me, and then now on with the real show. I'd like to hand you over to Thomas. So Thomas, thank you very much for your time today, and look forward to hearing what you have to say.
Thanks for having me here. So I've been looking forward to show something about lifecycle assessment in general, and especially our small plugin, DesignLCA, which we already see that a lot of international users are starting to test on their projects. I will start with a small presentation and a video about the workflow, and then I'll jump into a live Archicad and show you how it works. So let me just share my screen. Should be here. I hope you can see my screen.
Yep, we can see it.
Just very short about myself. Yes, I'm an architect, and I've been helping Building Smart make their chapter in Denmark. And an interesting part of that is the more we go into sustainability, the more important Open BIM will be. And there's a lot about IFC and how it's handling the CO2 values and the other parts of the information in the BIM models that are very crucial to calculating on environmental impact. So I think that BIM becomes more important now when we need to change the industry to be more green, and I think that Open BIM is a key for that. I also wanted to introduce my colleague. Her name is Sissel, and she's not here today. She has a bachelor in engineering, and she's doing her master right now with a focus on BIM and sustainability. And this half year, she's studying in Greenland. So she couldn't be here today, but she's the mastermind behind DesignLCA. She came up with the idea to build it into Archicad, this life cycle assessment. Did the first prototype with schedules and moving them into Excel, and was part of working with a CAD project in Hungary to do the coding of a real plugin. So I'll do my best to tell you about what it is, even though she's the brains behind it. I also want to introduce a Danish office called Linear, and we've been developing DesignLCA together with Linear. They're an architectural office in Denmark that are extremely focused not only on sustainability, but more specifically on upcycling. And what we found out when we started the collaboration with Linear was that they didn't do their own LCA calculations in the office. They were using an engineering office, and that's not a problem in itself, but it can be a slowdown when you want to do LCA in the early phases of a project. If there's a lot of exchange between the architect and the engineer, if you want to test a lot of different solutions and have these LCA calculations for each of them, it can be very time-consuming process and therefore also expensive for the building owner. So they were very eager to get some kind of tool that was easy to use and was possible to use in the early phases at the architect office. And we did 2 projects together with them before launching DesignLCA. The first one is the one on the right side of the screen, which is a competition in Berlin, Germany, where we did LCA calculations on 3 different ideas, and they chose, of course, the idea with the lowest CO2 footprint and won the competition because of the LCA calculation. And I'm not going to dive into the project, but it's a very interesting project by itself with a lot of building materials that are upcycled from the area around the building site. The smaller building on the left of the screen is our second project, which is also a sketch project, but with a building owner who wanted to build with a very, very low CO2 footprint. And to do that, you have to detail every part of the building, even though it's in the early design phases, to make sure that every solution is based on products with a low CO2 footprint. So that's also time consuming, and it turns the whole process on a project around, because you need to know a lot of, you have to gain a lot of knowledge about the project in the very beginning, but then when you go through the later phases, you're almost done. And what Linear found out was this DesignLCA tool changes the way that they sketch, because they can use LCA as a design factor. And I think that's the most important part of DesignLCA, that now it's another factor in the design of your buildings from the first sketch. So let's be a little bit more specific about what lifecycle assessment is. Generally, we have a problem. There's so much waste in our industry, and we're not very good at limiting the material use on buildings, and we have to change the way we build. Denmark is in the forefront of this, leaning on a lot of initiatives from the EU. There's the EU taxonomy, there's the Fit for 55, there's a Green Deal, and all that changes into legislation in each European country. And Denmark has been fast to make these new rules and laws and demands. So we have to do LCA calculation on all Danish projects. And Denmark is not alone in this. So there's a lot of European countries that already have legislation. Some of it is only on public projects. Some takes more phases of the life cycle into account doing these calculations, and some to take more. So it's not implemented in the same way, even though that LCA is an ISO standard. So an LCA is a defined method of working, but within that method, you can choose to include more or less data when you do the LCA calculation. In Denmark, 30% of the total CO2 footprint is from the AEC industry, so we have to change. What not very many people realize is only 1/3 of that footprint from the building industry is from building materials. 2/3 are from the energy use for operations. So that's heating, cooling, ventilation, lighting, and electric appliances. So we don't have to only look at new building systems with new materials, but we also have to look at how to limit the amount of energy that is put into the building during the use phase. When we do an LCA calculations, we have to include different stages or phases on the from the building life cycle. And the first phases are, I have a strange thing on my screen. Let me see if I can get that away. Good. So these different phases, the first phases are the raw material supply and transportation from where they get these materials. It could be wood, it could be sand, and transporting it to the factory. The next phase is the transport from the factory to the building site, and then the erection in the building site with all the energy that use. In Denmark, we don't include these phases in the LCA calculation. The next phases are the use of the building. It could be maintenance, repair, and refurbishment, but that's not included in the Danish LCA, but replacements are. And replacements are building materials that will not last for the 50 years that we calculate in LCA. So let's say you have windows that only last for 25 years, then you have to double the CO2 from the windows to see how much CO2 they will produce within the 50-year period. It could also be roof materials that only last for 35 years. You also double that because you have to change them, or facade cladding or different materials. Another phase is the operational energy, and we calculate all the heating energy, cooling, ventilation energy for the 50 years. Then we calculate an LCA including the end of life phase. And that means that even though some buildings will last for hundreds of years, we calculate as if they're torn down after 50 years. And then we have to include the CO2, not for the demolition and transport from the building site, but only for the disposal of the materials. And sometimes if some of the materials are easy to reuse, if they're made to take apart and put into a new building, then there's actually a recycling potential that we can get a little bonus for. So these are the different phases that are included in a Danish LCA calculation, and it would be more or less the same for LCA calculations in the rest of the world. DesignLCA is our tool, the free add-on for Archicad. And we see it as a very simple tool to use. And when we look at other LCA tools, they seem very complex. And that's not necessarily a bad thing. Sometimes you want to have a lot of different knobs to turn, and you want to be able to calculate even though there's no 3D model, or calculate even though there's no EPDs with CO2 values from the companies producing the materials. And we've chosen to make a very simple LCA calculator that only calculates on what you model in Archicad. And it's very close to the way that these LCA calculations are set up in different European countries. The phases I showed you before, you can look at them in this way also. So we have the phases from the product stage, the construction process, the use stage, and the end of life. And DesignLCA will let you include all the orange phases. And this will probably be more than you need, because the ones that we have left out are the ones where there's very little data. So it's really difficult to include in an LCA calculation. So you just take on in DesignLCA which phases you want to include, and then that's what is calculated. We only look at the global warming potential. So that's the CO2 equivalents for the greenhouse gases that are produced from the building. We do everything inside Archicad with this plugin, so you don't have to jump out and into some other application to do the energy calculation or something else. We only calculate on what is modeled. So if you don't include it in your 3D model, it's not included in the LCA calculation. Then we're very proud that we can calculate the CO2 from both material use and the energy from operations. Because as well as we know, there's no other tool that can do this. All the other LCA calculators, you have to jump out of them and into some other application to do the energy calculation, for example. Or you model in one application and then you do the energy calculation in then a second application, and then you put everything together into a third application to do the LCA. So this is a really clean workflow and easy to use. So I want to show you a video. It's a rather long video because I want to show you from scratch how we work with LCA. And when I say from scratch, it's using the Danish template. So that's already a little bit of cheating because in the Danish Archicad template, we have included the DesignLCA plugin. We have included that property set that you need on your elements to be able to calculate the LCA. And we actually also made a bunch of building materials with CO2 values and lifespan already included. And that means when you use this template, you can start modeling. And the second you put real materials on the model, it will start calculating LCA. If you don't have a template like ours, you might be able to get one from the local distributor of Archicad. And that means you can put composites on your project like I do here. You can see the exposure of the slabs, so I just want to fix that. Or otherwise, you can make your own materials with CO2 data and put it in your own template. And then when you model, it will automatically calculate the LCA. And that's a very nice way of working, so you don't have to find EPDs, these environmental product descriptions from the producers of the materials, and enter the CO2 on every material every time you start a new project. So in the video here, I'm modeling as fast as I can. And not only the building, but I also added a terrain and a small entrance. And to do the energy calculation later on, that is also included in the LCA calculation, I need to place rooms inside my building. And I don't think it makes sense to just have one big room for the whole building. So I just want to add some partition walls. And they have a CO2 footprint also. So that's just a more precise LCA calculation. The same thing with the staircase that also produces some CO2. So let's add those things that we know will be in the building from scratch. Let me just look at this in 3D. I can see the top step. I have made a small mistake, so I'll just make that better. You can also see that my walls, partition walls, are going through the roof. So I'll just connect them also. I guess you guys out there that you are comfortable with modeling in Archicad, so this is probably the same mistakes that I do that you might have done when you started using Archicad many years ago. So of course you don't do that anymore. And now I'm placing the rooms inside the building, and they will determine the outside walls for the energy calculation. And to determine the roofs, I need to cut the zones with the roof. So the zones have to touch all the outer parts of the building. So here you can see what I think is a sweet spot for the LCA calculation in detail level. So we need materials, but it doesn't have to be a fully detailed building. And now I can open my DesignLCA palette and look at the LCA calculation. And it's already there. I don't know if you can see it on your screen, but I see 83,000 kilos of CO2 on the building so far. I can jump into my settings. See, I calculate over 50 years. I have ticked on the phases that I need. And I can also look at my materials. So in the DesignLCA, I have a material browser, and I can see the different materials and the CO2 values that are linked to these materials. I can see if they're calculated by cubic meter or square meter or kilograms, and how long time the service life is for each material. So I think we need to do the energy calculation now. So I'll jump into energy evaluation. And this is what was formerly known as EcoDesigner STAR. And then here I do a thermal block, and I put the operation type on it, and I add all my rooms to this block. So it's just living space, so all the rooms will be attached as that. But if you have a building that is partly offices, partly apartments, then you have to do two different thermal blocks. I just added the heating systems and the ventilation system. And now I just look at the comfort zones that must be between 20 and 23 degrees every day of the year. I can see the location of the project. And in our template, the project is placed downtown Copenhagen, but you can also enter your own place from Google, and it will, EcoDesigner STAR will automatically download the weather data with rain and mist and wind and temperature. So the simulation of energy is precise no matter where in the world the building is placed. And then I can see the building systems. I added district heating and natural ventilation, and I can do the settings in here. I'm an architect, so I'm not going to touch anything of that. I can also see that we have added how many kilograms of CO2 per kilowatt hour. So all the different energy sources has a CO2 footprint. You need to update the zones to register the different walls and slabs and roofs. And here the list are, and you can see the different composites put on the different elements. And you can see the U value is automatically calculated. Then you can see the windows and the doors, and that's a little bit more difficult. So for windows and doors, you have to define what kind of frame it is. Is it a wooden frame? And how good is the U value from standard to ultimate in 5 steps? So you don't have to be an expert in any ways. You need to set how many layers of glass in the windows and what kind of door leaf also. And if you want to, you can also add a shading device. So that could be a sunscreen or an overhang or something else, louvers outside the windows. Now I think I'm ready to do my energy calculation. So I do the report, and actually I don't even have to look at the report. I don't need it for anything. I just need to send to DesignLCA. So I export the EcoDesigner STAR data to the plugin we have. And now I can see that I went from 83 kilograms to 118 because now the CO2 from the operations has been added. And what I just did here was I changed the composite. I change it again now, and I test different kinds of structures. This is a massive wood CLT, cross-laminated timber structure with an outer cladding of wood. I can change my roof composite. This one was went in the wrong direction and had more larger CO2 footprints. So let's go back to the one I had before. I can change my slabs also to CLTs. And then I can slowly change my project so the CO2 footprint just gets lower and lower. Before I put the U value on the windows, here I have to tell if my windows and doors, what kind of structure it is to add the CO2 from the material use of windows and doors. And I'll show you that later in slow-mo, how that is done. And every time I update my LCA calculation, I can see exactly how much better I do. Then we have made a clever thing called the material CO2 report. And this is the tool you use to figure out what materials to change. I just found out a mistake I made. I put out the wrong material on this slab outside the building. So now I have the right CO2 footprint, but in Danish regulatives, you don't have to include it. So I'll just say exclude this object and it will not be part of the LCA calculation. But in here, I can see the dark bars are the layers in the CO2 and the gray bars, light gray bars are the materials. So the biggest problem is my gypsum on outer walls. So I just remove one layer of gypsum and I can see my CO2 footprint is lowered. So that's the whole workflow with DesignLCA. And now I start changing my project. I change the pitch of the roof. I change the size of the windows. I add some more windows. And at some point, I'll also stretch a part of the building so I get more square meters. But I also get more material used for walls and slabs. So in all other LCA calculators, I should almost start from scratch because all my quantities have changed now. But with DesignLCA, I just have to redo the energy calculation. I'll close down this palette for LCA, and I'll go back to my energy evaluation in EcoDesigner STAR. Come on, close. And all the settings I did before are still here, so I only have to update the zones and update the calculation. And then I'd have to export to DesignLCA once more. And I can just go check in my settings if it got the new energy CO2, it did. So I can see my updated result. And now there's much more CO2 from this project because I added a lot more windows, more roof area, more wall area, and also got a bigger house. So that makes sense. So that was the whole workflow video of DesignLCA. And I'm assuming that you're a little bit confused because it was very fast, so I'll dive down into a live presentation just in a second. So how to get started? Let me get out of here and into my browser. So if you go to DesignLCA.com, you'll see this very small website, and it's really easy. So you just go to the download now, and you can download with just a few clicks the latest version of DesignLCA. The latest version is called 4.1. And it's a plugin that you have to install. I'll just go back. And then it's a property set that you also have to add to your project. And then it's a manual. So here you see the manual. And it will tell you a little bit about what LCA calculation is. It will tell you how to install the plugin and the property set. And then it will slowly tell you about how the whole LCA calculation is done within DesignLCA. It will even help you out with a few of the tricky parts. So one of them could be this. If you do a curtain wall in Archicad, it will automatically be calculated within DesignLCA. But the standard curtain wall in Archicad is a massive framing of aluminium, and that will make the heat go directly through the facade. So you need a lot more heating, but it will also have a huge CO2 footprint from all the aluminum. So what you should do is change for this hollow framing, or even better, draw your own if you have a specific frame for the curtain wall you need. Doors, windows, stairs, railings, a lot of help in the manual. Here's the energy calculation, and in the end, how to export the LCA calculations to Excel or what you need. So that's the manual. So go to DesignLCA.com and download the plugin, and everything is taken care of there. Here I have my Archicad model for the project you just saw. I added a little thing. I added this advanced profile wall that can also include the top of the terrace. And you see the section. So it's a little bit different than what you saw in the video. And one important thing about DesignLCA is this property set that you put on your model. So if I go to the wall settings, I can see here under classification and properties that I have this LCA elements. And what I can do here is I can say include true or false. So this is how I determine if I want to include this element, this object, into my LCA calculation. DesignLCA will only calculate on what is shown actively in the model. So if you turn something off, put it on a layer and turn that layer off, it will not be included in the calculation. So that's another way of controlling what is included and not included. Another thing you can do is you can set the percentage. So let's say you reuse some upcycled bricks that only have 10% of the CO2 footprint of normal bricks. Then you can just enter 10% here, and this element will only calculate as 10% of the original value. The property set also works on doors and windows. So if you go to the doors and windows settings here, let me just read. And again, I go down to LCA windows. I can set the frame type. And this is in Danish, I know, but if you use the international version of DesignLCA from DesignLCA.com website, then you'll get an English drop-down menu. The other thing you can set on Windows is the amount of layers of glass, 2 or 3 layers. I go with 3 layers on this project, which is the standard in Denmark. And of course, again, I can set the contribution to 10% if it's recycled windows. In the DesignLCA menu, I have my settings. So let's just go through them. So normally you would calculate for 50 years. So that's the setting you have up here. And then everything else is automatically taken care of. So Archicad will take the floor area from the rooms that you put into the project. But if you want to determine it manually, you can just remove the tick mark and enter how many square meters there is. And this gross floor area is used to divide the amount of CO2 from operations if you want to see it with CO2 per square meter or per square meter per year. Then we have a reference floor area, and that's automatically the same as the gross floor area. So it will also be 145, but if I want to change this, I can do it manually. And the reference floor area is used to divide the CO2 from the building materials. So this lets you have 2 different areas to use for dividing the material use CO2 and the CO2 from the operational use. And that's mainly because that's what we have to do in Denmark. We have to split this up in 2 different areas, where the reference floor area will include balconies, staircases outside the building, attach carports and stuff like that. Then if I have solar panels, I can add them to my energy analysis. I just need to know exactly how big they are, how effective they are, and what angle they're placed in. And if that's too much information in an early phase, then I can just move a tick mark more, and I can enter manually, let's say 800 kilowatt hours a year from solar panels. But in Denmark, you're not allowed to just add as many solar panels as you want to. You can actually only add 25 kilowatt hours per square meter per year. So therefore, you can also set a maximum here. We normally use the same amount of CO2 per kilowatt hour as the energy that is used in the calculation for lighting and electrical heating. But if you have some other value, feel free to enter it yourself. And if you don't want to use the EcoDesigner STAR energy calculation, but you have your own energy calculation, you can remove a tick mark more, and you can just enter it up here in kilograms of CO2 per year. The next part of the settings are the different phases that you want to include in your calculation. So that's easy. And if you have some reference values that you want to compare your calculation to, you can just enter them here. So let's look at the main palette of DesignLCA. And what I have 1 column here, which is my global warming potential. So that's the complete total amount of CO2. It's divided down to CO2 from operational use, from building materials, from doors and windows. And the reason that doors and windows are, they have their own part of this calculation is that you can set the lifetime of doors and the lifetime of windows separately here. Then I have the CO2 from inventory. And in Denmark, you don't have to include inventory, so that's a 0. Then I have the CO2 from installations, so from that, all the piping and the ventilation shafts. And normally I would just, when I'm sketching, I would put off 10% on top of the CO2 for installations. But in Denmark, we're allowed to have a set square meter value for installations. So I just enter it manually. So you can enter per square meter per year, or you can enter the total amount of CO2. The last one is the construction process, and that's not included in the Danish LCA calculations either. So it's 0, but I could just put 20% on top if I wanted to. Let's go back to the 0. It looks better. Then I have a pie chart. That's not very useful. I know that it needs to be more or less half blue, half orange. If there's no blue part, I forgot to do the energy calculation. If it's all gray, it's because it's an international project where doors and windows are entered in meters instead of millimeters. Then we have to change the properties. And then here I can see my project as blue compared to the different reference values that I entered in the settings. If I go and DesignLCA to my building material settings, then I can see I have a lot of different materials here. All the one called DKLCA is the one I entered in my template. And if I look at these concrete elements, I can see that I have different CO2 values for each face. But I only have the faces here that I used in the Danish calculation. So if I press cancel, I go to settings and I add my D face and go back again. Then I can see now I have also an extra face included in the calculation. And if I enter something in my template, even though I had it turned off before, it will still remember in the background if I turn it on. I can see if my material is calculated in square meters, cubic meters, or kilos. So if it's cubic meters, it will just take the geometry of the building, of the model, and use it for estimating the CO2. If it's square meters, it will actually calculate square meters of the material, so the thickness doesn't matter. And if it's kilograms, it will look at the physical properties of the building material and calculate from cubic meters to kilograms using that. So that's the materials I use. So why did my building components suddenly go wrong? I don't know what I did. I must have done something here. Oh, I added the D face. So let's just go back and exclude that and see how that works. Oh, great. Now I'm back again. So if I have this project in the background and I can see I have 10 kilograms of CO2 per square meter per year, and that's too much for me. I wanted to lower it. I need to figure out what to change. And that will probably be some kind of material. So to do that, I go to my material CO2 report. And this is a super clever tool. So I can see my different layers here. So I have outside walls. I have my foundation. I have internal walls. I have my slabs, I have my roof construction, my outside terrain, and my staircases. But it doesn't matter what layers I have, you'll get the layers that you have in your project. Then for each layer, I can see this dark gray bar will show me that the layer with the most CO2 is my outside walls. So if I should change something in my model, it would probably be on outside walls. And then I can see all my materials, building materials on each layer. And that's super clever because let's say I have some concrete in my foundation. I don't want to change that necessarily. I might want to change concrete on some other walls or slabs, but not in my foundation. So therefore, it's really nice that I have them divided by layer. So let's look at these outside walls. The material that has the biggest CO2 footprint is my wood fiber insulation. So if I should change something about this project, I would probably look at my insulation in outside walls. That might already be optimized. So I can just look what else do I have to work with. I have my concrete in my foundation. I'm not going to mess with that. But then I also have my gypsum in my internal walls. So that might be something I could change perhaps to wooden boards, something else. So I think this is where I'm going to work after the webinar to try to lower the CO2 on this project. But this material CO2 report is a super clever tool for optimizing the carbon footprint of your project. Then I also want to show you something that we think is clever. So here I'm on my plan drawing, and I have my CO2 calculation, and I can actually place this on my drawing. Let's zoom out a little bit. And I told you that after this webinar, I'm gonna work with the partition walls in my project and change them. So I wanted to put some text on this one. Where's my text here? And this one, just go here. This is partition walls with chips. I'm not sure if I spelled everything right in English. So now I have a calculation showing my current state of the project. And if I want to lock that down, I can open the settings for it and turn it off update from add-on. And no matter what I do, this will just be frozen. So I can place a new one after my changes, and I can see how my progress is changing material by material, changing the heating system, rotating the building on the side, changing the pitch of the roof. All the changes I do, I can make a LCA calculation and freeze it. And I can actually do the same with the material CO2 report. I can also place that one if I want to. And in the same way, I can turn off the update from add-on, so I can see exactly what's included in the calculation above. So we think that's super clever way of working with LCA. If I want to get out of Archicad, I can generate an LCA report. Just place it on my desktop and open it right away. And this will move my calculation from Archicad into Excel. And I have the whole calculation as you saw before here. And I can now work with different values if I want to change anything. If I want to see the material CO2 report, it's also there in another part of the Excel. So that's more or less how this works. Let me see if I can stop sharing my screen and get back to you. So Nathan, could you follow the video and the workflow, or do you have any questions?
We have got some great questions from the audience, so I'll crack straight into those. Thomas, thank you very much for your time today and sharing this information. I know that for many, this is a very important part of the process and where the architectural profession is leading and where we need to be heading. So thanks very much to your team for putting that together.
Thank you for having me, and I'm so glad that this is of interest of a lot of Archicad users, and I'm looking forward to see a lot of more sustainable building projects in the future.
Too much sustainability. We need more of that. But thanks once again. Now, I would like to make everyone aware that we have our next episode, our next webinar coming up on Wednesday, the 10th of April. Now, this is already up on the community website, so you can register for it. I'm not going to nominate the time of day that it is because it is at a different time for everyone that is online today. So it's nice and early over in Europe at the moment, whereas it's, what can I say? It's getting into the evening over here in Australia. So thank you very much for attending today. And I look forward to catching up with you in a month's time for our next episode. Thank you.
Thank you. Bye.